In this question, we are given three sets of functions in different forms, and we have to determine whether the functions are even, odd, or neither. So let's start off with this first function here. Well, we can just graphically tell whether a function is even, odd, or neither. If it's even, it's symmetrical about the y-axis. And if you notice, this function is not symmetrical about the y-axis at all. If you'd flipped this part of the function onto this part, you wouldn't get this left side here. Is it odd? Well, if a function is odd, it means it's rotationally symmetrical about the origin. Or another way to look at an odd function is if you reflect it in the y-axis and the x-axis, you get the same function. Well, if we were to take this function and reflect it in the y-axis, we would get something looking like this. And then if we reflect this new function in the x-axis, we would get something looking like that, which doesn't give us our original function that we were working with. So we know it's neither even or odd. So the answer for A is neither. What about part B? Y is equal to 6. Well, y equals 6, we know that that's what? How does that look like? Well, it's just a horizontal line at a y value of 6. And notice graphically how this is symmetrical about the y-axis. Because if we reflect this function on the y-axis, we would get the same function. So right away we can tell that this function is even. What about here, this table of values? Let's plot these points out. So 0 and 0, -1 and -3 would be like, let's say, here. And then -2, -36 would be down here. 1 and 3 would be over here, and then 2 and 36 would be up here. Notice how if we join these points, it almost resembles like an x cubed sort of shape. It's not that, it's just points that we are plotting. We're not joining these points, but it sort of takes that shape. And notice that this function here, these points are rotationally symmetrical about the origin. Or another way to look at it is if we reflect these points in the y-axis, these points here, what's going to happen is they're going to end up over here, and then these points are going to end up over here, and then if we reflect those points again on the x-axis, we end up with these original points that we had at the beginning. So if you reflect it in the y-axis and the x-axis, you get the original points. Another way to describe that is that these points are rotationally symmetrical about the origin. So we know that this function given with this table here is odd. So whenever you're given functions like this, if possible, if you can graph them quickly, and then you can tell, is it symmetrical about the y-axis? Is it rotationally symmetrical about the origin? If so, it's even or odd respectively. If not, then it's neither.